Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new topic, that is a decimation in frequency fast Fourier transform. Basically, in last video we have studied a DIT FFT, that is a decimation in time fast Fourier transform. Now we are going to do the same thing but in reverse manner, because a frequency is a reciprocal of time, which means the butterfly diagram will be perfectly opposite to that of a butterfly diagram that we have studied in DIT FFT. So first of all, we will start the derivation and we will start with the definition of DFT. So let's see the definition first. So by the definition of DFT, a DFT of any discrete time sequence x of n is represented in DFT by x of k, and the formula and the equation is, or you can say the definition is, a summation n value varies from 0 to n minus 1 x of n into omega n to the power kn. Now basically what I want to do, I want to divide this summation value into two parts. The first one, basically here the total time sequence, the summation value started from 0 to n minus 1 means what? We have total n number of points or n numbers of samples. So this n stands for the number of samples present in x of n. Now if we want to divide it into two parts, then I will divide into equal two parts, like n by 2 parts. So if the summation value starts from 0, then my last value is not always n by 2, it will be n by 2 minus 1. So in first part, or if we divide this whole samples n into two parts, then first summation value start from n equal to 0 to n by 2 minus 1. This n is divided into two parts. That's why the first summation, the value or the highest value of first summation is n by 2 minus 1. Then what is the lowest value of next summation? Because after n by 2 minus 1, the next step is always n by 2, because if we want to achieve a next number, we will always add 1. So if we add 1 in this, then 1 minus 1 will get cancelled, so we have only n by 2. So I can say that the next starting value will be n by 2 for this summation, and the highest value is always n minus 1. Now I'm going to replace some values. Basically in second summation, I'm going to replace this n value by n plus n by 2. So I'm going to replace only second summation n value by n plus n by 2. The first summation value will remain same, because I'm going to change only the n value but in second summation. Now look at here, if I shift this n by 2 on right hand side, then of course this n by 2 is subtracted from the lower limit as well as from upper limit. So look at here, here we have a plus sign for n by 2. If I shift this n by 2 on right hand side, then automatically n by 2 will get cancelled, so lower limit of this summation is 0. But what about upper limit? If we want to subtract n by 2 from n, then n minus n by 2 is always n by 2, then upper limit of this summation will be n by 2 minus 1. Why we have done this thing? Because I want to keep this both summation value same. That's why I have replaced this n by n plus n by 2. Now look at it in the last part. Here we have omega n to the power k into bracket n plus capital N by 2. So what I'm going to do, I'm going to multiply this k inside this bracket and I'm going to split this power. Now how to split the power? E to the power a into b is always e to the power a. How to split the powers? We have studied one formula. E to the power a plus b is always e to the power a into e to the power b, which means if we have omega n to the power kn plus kn by 2, then after splitting the powers, what you will get? Omega n to the power kn into omega n to the power kn by 2. So first of all, I will multiply and then we will separate the orders. Now I will split both the orders. Why I have divided or why I have separated these two orders? The reason is this term is a constant term because this whole summation value is totally depends on the value of small n. And in this last part, we don't have any small n value. That's why I have separated the orders. And now I'll shift or I will write this value outside this summation. But we know that omega n to the power kn by 2 is having some values. So what was that? We'll see. In this part, I'm going to keep n by 2 inside and I'll write k in the power of omega n to the power n by 2 raised to k. Now, we will calculate the value of omega n to the power n by 2 first. Omega n to the power n by 2 can be written as e to the power 2 pi by n into n by 2. Basically, omega n, the value is e to the power minus j2 pi by n. If we write here kn, then kn will be multiplied with e to the power j2 pi n. Now here, from this equation, I can say that these two will get cancelled as well as this n will get cancelled. So what is remaining? E to the power minus j pi. Now, what is the formula of e to the power I theta? The formula is e to the power I theta is cos theta plus or minus I sin theta. If we have plus or minus sign in the power of exponential term, then that will affect the sign of imaginary term. The sign of imaginary term also plus or minus. So right now here we have a minus sign, so the imaginary term will also carry the minus sign. So as I said, e to the power I theta, this one is nothing but imaginary term and theta is my pi. Formula is cos theta minus I sin theta. So here I have used a j value instead of writing pi I. Now sin n pi or sin pi is always 0, so no need to write any values for this, but cos pi value is always minus 1. So finally my omega of n to the power n by 2 value is minus 1. Now if I write power k over here, then what will happen? We will have a power k over here also. So we will write a power k here also. Now this power k will be there here also as well as here. So I can say that in the power of minus 1 we will also have a k if we write a power k over here. So this whole bracket omega n to the power n by 2 raised to power k is replaced by minus 1 to the power k. So this part is replaced by minus 1 to the power k. After this equation, we will divide our function into two parts. Like we can split our function in even parts as well as in odd parts. So how to divide it? Let's see. And what will we get after the division? Let's see. Now look at here. Before moving to even and odd parts, I can say that the summation value in both the parts is same, as well as omega n to the power kn is same. So what I'm going to do, I'll take summation value common as well as omega n to the power kn common. So what is remaining inside this bracket? X of n plus minus 1 raised to k x of n plus n by 2. And this whole equation is multiplied by omega n to the power kn. Now I'm going to divide my x of k samples into two parts. As I said, we will divide it into even parts and odd parts. So let's say my x of k equation can be written as, now here x of 2k value is for even, whereas x of 2k plus 1 is for odd, which means x of k is a combination of odd samples as well as even samples. So first of all we will write the equation for even samples and then we will write the equation for odd samples. Means what? All the k values which is mentioned in this equation is replaced by 2k, and for odd samples all the k values replaced by 2k plus 1. Well, this equation is for even samples. Now I will write the equation for odd. Now look at here. We will solve first of all omega n to the power 2kn and omega n to the power 2k plus n, and then later on we will solve minus 1 raised to 2k plus 1 and minus 1 raised to 2k. Basically minus 1 raised to 2 is always 1, and 1 to the power k, what will be the value of 1 to the power k? This k is nothing but this value is actually starting from. Now first of all we will solve this 2k n value, omega to the power 2k plus 1 l value, next minus 1 raised to 2k plus 1 and minus 1 raised to 2k. But before moving to this, what is the sequence for k? As we have divided our k value into two parts, that is in even and odd, then my k value for both the equations will start from 0, but last value will be not n minus 1, it will be n by 2 minus 1, because we have divided the sequence into two parts. Till this equation our k value started from 0 and the last value was n minus 1, but after splitting this equation into two parts my k value will be different. I'll show you on next page. So for x of 2k and for x of 2k plus 1, my k value started from 0, but the last value is always n by 2 minus 1. Now, first of all, minus 1 raised to 2k can be written as the minus 1 raised to 2 and whole power raised to k. Now, minus 1 raised to 2 is always 1 and 1 to the power k. Answer is, basically here we are going to substitute the value of k from 0 to n by 2 minus 1. So 1 to the power k is always having a value 1. Now we will move on to next value, that is in even part we have calculated the value is 1, but in odd part we have the value that is minus of 1 raised to 2k plus 1. So as I said in last part also, we can divide our powers into two parts, like minus 1 raised to 2k and minus 1 raised to 1. Now we have already calculated minus 1 raised to 2k value, which was 1, and minus 1 raised to 1 is always minus 1. So 1 into minus 1 is, answer is minus 1. So minus 1 raised to 2k plus 1 is replaced by minus 1, whereas minus 1 raised to 2k is replaced by 1. Now one more thing we are going to calculate, that is omega n to the power 2k n. Now we have studied 1 to del factor formula, that was e to the power minus j2 pi k n by n, and here we have multiplied this power by 2. So I'm going to write here a 2. Now basically we can write these 2 in the denominator of n also, because a denominator like a 2k k by n upon 2 is always nothing but this. So I'll shift this 2 in the denominator of n, which means both the formulas, like the formula for omega n to the power k n was, so when we have omega n to the power k n, we have this formula. But look at here, e to the power minus j2 pi k n, where this capital N is replaced by n by 2, which means this formula can be written as the numerator part or the power part of this e to the power function remains same, that is the integral factor, the omega value raised to kn will be there, but this n value is now replaced by n by 2. Now we have one more formula or one more value in this last equation. That equation was, this one is for even, whereas this one is for odd. Omega n to the power 2k plus 1 into n. So first of all we will split both the orders. So we have calculated this omega n to the power 2k n value, and this value we have got the answer. For this value we have got this answer. So we'll replace this value by omega n by 2 raised to kn into omega n to the power small n. I'll substitute all these four values in my last even and odd equation of x of k. Now I'm going to substitute all the last values in my even sample of x of k and in odd sample of x of k one by one. Now this is the equation for even sample of x of k, whereas this one is the equation of odd sample of x of k, and for this also my k value varies from 0 to n by 2 minus 1. Now, what I'm going to do, I'll write this omega n to the power n inside this bracket, but only for x of 2k plus 1. Now, plus into minus, our result is minus. I've multiplied this whole value by omega n to the power n, and this whole bracket is multiplied by the last value, that is. Now, I'm going to write my x of 2k value and x of 2k plus 1 value once again, because I'm going to do some substitution in both the equations. Now, these two are my equations of even samples and odd samples. Basically, in this first part, the x of n plus x of n plus n by 2, I'm going to replace this whole equation by some different variable. So let's say g1 of n is nothing but my x of n plus x of n plus n by 2, and this whole part I'm going to replace by so after substituting these two values in this equation, then my new equation becomes now in x2 of k and x of 2k plus 1, we have actually what we have done, we have divided our n point into n by 2 points. Like the whole n samples is divided into two parts. First one is for even and the second is for odd. So my total n samples is also divided into two parts, which means suppose if we have a calculation for 8-point DFT, then this n by 2 value will give us a value of 4. Now, this 2k value we have calculated, this g1 and g2 we are going to calculate, but as I said, if we have divided our 8 points into 4 points, then this n value is also replaced by 8, and the 8 by 2 value becomes 4. Here also we will do the same thing. This n is replaced by 8, so n by 2 will becomes 4, and this n is also replaced by 8. So for 8-point DFT, I'm going to write the equation for g1 of n and g2 of n. I'm going to replace all the n by 8. Then let's see what will be the solution, because I'm going to substitute my n values in that. But as I said, we have divided our sample values into 4. Like 8 points is divided into half parts. That is, we have got the 4 samples, which means we can substitute my n values only from 0 to 3, not up to 0 to 7, because we have divided our samples value into 2 parts. Now, as I said, we have 8 samples, but we have divided that 8 samples into 2 parts. So to calculate g1 of n and g2 of n, we are not going to substitute my n values from 0 to 7. As I said, this calculation is for even and this calculation is for odd. And in 8 points DFT, our samples are divided into 4 parts, means our counting or the sample value will also start from 0 but up to 3, because we are going to solve only 4 samples. In 8-point DFT, we have 4 even samples and 4 odd samples. So this n value I'm going to substitute and the value will start from 0 to 3. Here also I'm going to substitute my n values from 0 to 3. So if I substitute my 0 to 3 value in these two values, then what will be the result of g1 and g2 of n? Let's see. So we are going to calculate n by 2 points from n point DFT. So basically our g1 of n equation is this, and where, as I said, my n value start from 0 to n by 2. But if we want to calculate the g1 of n for 8 points, then all this n is replaced by 8. Now if this n is replaced by 8, then 8 by 2 becomes a 4. And look at here, if I replace this n by 8, then 8 by 2 becomes 4, and 4 minus 1 is 3. So my n value starts from 0, but max to max it will reach up to 3. So which means we can substitute my n values from 0 to 3. So let's see what will be the result after substituting n equals to 0 and n equals to 3, all the samples in this equation. So these are the values of g1 of 0, g1 of 1, g1 of 2 and g1 of 3. Similarly, we will calculate a g2 of n values. So if I want to calculate this whole equation for 8 points, then for 8 point, all the n is replaced by 8. Now look at here, if this n is replaced by 8, and then 8 by 2 is 4, so we have x of n plus 4, and it is multiplied by omega 8 to the power n. Now here this n is also replaced by 8, so 8 by 2 is 4, and 4 minus 1 is 3, which means my n value varies from 0, but it will varies up to 3. Now we will substitute all my n values in my g2 of n equation. So I have replaced all the n by 0 to 3, and this is what I have got the equation. Now I'm going to draw the butterfly diagram, but I'll start from x of k, where I have got the 8 samples, and then we have calculated the even samples and odd samples, that is g1 of n and g2 of n. And g1 of n and g2 of n, according to this or according to these equations, we will draw the butterfly diagram. Now basically our g1 of 0 value is x of 0 plus x of 4, g1 of 1 value is x of 1 plus x of 5, similarly x of 2 plus x of 6, and x of 3 plus x of 7. So basically we are going to calculate g1 of 0, g1 of 1, g1 of 2 and g1 of 3 values, but using these 3 calculations. So I'm going to place, or I'm going to draw the diagram for g1 of 0 and g1 of 3. All these 4 values I'm going to calculate, but using a graphical method called butterfly diagram. So let's see how to get the answers or how to draw the graph. Now As I said, my g1 of 0 is the addition between x of 0 and x of 4. That's why I have directly taken the x of 4 sample value and added with x of 0. Similar g1 of 1, g1 of 2, g1 of 3, I have done the same values. Just taken the x of 5, x of 6, x of 7 values and added with 1, 2 and 3 respectively. So automatically you will get this answer. But how to calculate g2 of 0 to g2 of 3 values? We have derived the calculations part for g2 of 0 to g2 of 3. We'll see that first so that you will get the idea what to do. Now, basically g2 of 0 value is nothing but the simply subtraction between x of 0 and x of 4. We have placed the adder sign, that is plus sign, at the end of or at the start of g2 of 0. Now, if we want to change the sign, then what you will do? I'll simply multiply x of 4 value by minus 1. Similarly, in all these rest of the cases, x of 5, x of 6, x of 7 values are having a minus sign. So what I'm going to do, before adding, I'll multiply minus sign with all these 4 terms, and then we are going to add all the values. And after adding, we will multiply it by omega 8 to the power 0, omega 8 to the power 1, omega 8 to the power 2 and omega 8 to the power 3 with all the addition or these result values. Then you will get the g2 of 0, g2 of 1, g2 of 3 and g2 of 2. So as I said, before moving to plus sign, we will multiply all these 4 samples by minus 1. So automatically after this dot, all the samples will carry a negative sign. So automatically x of 0, from x of 0 your x of 4 will be subtracted. Here we have plus sign, so minus into plus becomes minus, so automatically x of 4 sample will be subtracted from x of 0. But you will not get answer of g2 of 0 directly, because we have to multiply this result by omega 8 to the power 0, then you will get the answer of g2 of 0. Similarly, if I multiply all the results by omega 8 of 1, omega 8 of 2 and omega 8 of 3, then you will get the values of g2 of 1, g2 of 2 and g2 of 3. Now, here we have divided our all 8 samples into a 4 sample, that is into even block and odd block. Now, the even block result is represented by x2 of k and odd block result is represented by x2 of k plus 1. Now, for even block, our k value always start from 0 to 8. Basically, for x of k, our numbers or the k values always start from 0 to 8, 7. In this x of k, after calculating g1 and g2, our result will be divided into 2 parts, that is in even part and odd part. Even part is represented by 2k and odd part is represented by 2k plus 1. Well, basically I have taken the sample example of 8 points. So as 8 points is divided into 4, or 8 points is divided into 2 parts, which means you will get the 4 samples in even and 4 samples in odd. So our total n samples are now divided by 2. So you will get n by 2 value. N by 2 means what? Your k samples are now divided by 2. Means we have the 8 samples, so 8 samples are divided by 2. So 8 samples are divided by 2 means what? You will get the 4 samples. But if we counting starting from 0, then last value is always n minus 1, means what? 4 minus 1 will be nothing but the 3. So we will add 0 to 3 value in this part as well as 0 to 3 value in this part. So if we add 0 over here, then x of 2 into 0 is always x of 0. If we add a 2 over here, or simply first of all we'll substitute 1, then 2 into 1 is 2. If we substitute 2, then 2 into 2 is 4, and if we substitute 3, then 2 into 3 is 6. So automatically you will get this all the even part answer. But how to get the odd parts? We will add 1 in that. Means if we add 1 in this, then you will get x of 1, 1 in this, then x of 3, x of 5 and x of 7 you will get. But now what is important, we have to find out the result of a 4-point DFT so that you will get the answer of this even part. So how to get this 4-point DFT answer? I'll show you. Now we have to find out the 4-point DFT. Basically we have divided 8 samples into 4 parts. Now we have to find out the 4-point DFT. So I'm going to divide my g1 of n and g2 of n into 2 parts, that is in odd part and even part. So let's say my p11 of n and my p12 of n is my even part and the odd part of g1 of n respectively. Now we will take the help of one equation that we have used in derivation. I'll show you which one is that. Now this g1 and g2 is the equation where we have separated our x of k part into two, like x of n and x of n plus by 2 and x of n minus x of n minus by 2. We have used these two equations. So we will use the same equations to find out p11 and p12 of n equation values, that is even and odd values of g1 of n and g2 of n. Now we will use the same equations, but in this same equation we have used x of n plus x of n by 2 is replaced by g1 of n and x of n minus x of n plus n by 2 is replaced by g2 of n. So we'll do the same thing to calculate a 4-point DFT. So I'll show you what I'm going to do. Let's say my p11 of n is nothing but my even part, and according to even part we will use only this equation as I said in g1 of n, and p12 of n is my odd part equation, so we can write g1 of n minus g1 of n plus n by 2 into omega n to the power n. But basically we have divided 8 point into 4 parts, but again we want to divide these n parts into 2 parts, which means right now we are not going to write this n by 2. We will write n by 2 by 2, here also n by 2 by 2, and here also this n by 2 is again divided by 2. So what will be the final equation? So here we have divided our samples in now again in 2 parts, which means our 8 samples are now divided into 4 parts. So 8 by 4 means what? You will get only 2 samples, that is 0 and 1, which means in both the cases my n value varies from 0 and up to 1. So we will substitute 0 and 1 value in these 2 equations. First of all, I'll substitute p1 of 0 in this equation. I'll substitute n equals to 0. Now for 8 point, this n is replaced by 8, so 8 by 4 is 2, so we can write. Now I'll substitute n equals to 1. So p11 of 0 and p11 of 1 is nothing but g1 of 0 and g11 of 2, and p11 of 1 is g1 of 1 plus g1 of 3. Now we will calculate the p1 of 2, that is the odd part of g1 of n. Now my p12 equation is g1 of n minus g1 of n plus n by 4 into the whole bracket multiplied omega 4 is to n. So here I will substitute n equals to 0 and equals to 1 equation. So first of all, I will substitute n equals to 0, so all n will be replaced by 0. Now n by 4 means for 8 point it is n equals to 8 and 8 by 4 is 2, so we can write 0 plus 2. And this n is replaced by 0. So what is the outcome of p12 of 0? Now we will substitute n equals to 1. So we have calculated the even part values and odd part values of g1 of n. Now we will draw the butterfly diagram first of all for g1 of n. Look at here. We can calculate p12 of 0 and p12 of 1. Basically we have calculated the right hand side, that is this one was. Now look at here. Our p12 of 0 is nothing but the subtraction between g1 of 0 and g1 of 2, that is this is what we have adder. means what? This adder will add G1 of 0 and G12 of 0. But what we want? I want a minus sign in front of G12. So what I'm going to do, I'll multiply it by minus 1. So automatically minus into plus becomes minus. So G1 of 2 value will be subtracted from G1 of 0. But after this subtraction, we have to multiply it by omega 4 raised to 0. So we'll write here omega 4 to the 0. Similarly, P12 of 1 is nothing but the subtraction between G1 3 and G1 of 1. So this G1 of 1 will be added with G1 of 3, but this G1 of 3 will carry the minus sign, it means we'll multiply it by minus 1, and this whole calculation is multiplied by omega 4 raised to 1. Now, how to calculate P11 of 0 and P1 of 1? We have seen the equation also. Basically, the P11 of 0 is the addition between G1 of 0 and G1 of 2, which means here we'll directly connect this line to adder. So automatically G1 of 0 and G1 of 2 will get added. Similarly, we have done the same thing with G1 of 1 and G1 of 3. So automatically we'll get the answer. And after this addition, we don't have any values of omega 4 raised to 1 and omega 4 raised to 0. Now, we will calculate n by 4 point DFT. But here, we have only 2 samples. Now, let's see what is the result of n by 4 point DFT, n by 4 point DFT. But the second part is remaining. This one is the even and odd part of G1 of n. Now, we will calculate the next even and odd part for G2 of n. So let's say P3 of 1 and P4 of 1 are the even and odd parts of G2 of n respectively. So how to write the equation? As I said, we can write the equation of P1 of n and P4 of n. Why I have written n by 4? Because we have divided the sample value twice. First of all, we have calculated G1 of n and G2 of n. So already we have calculated a half part. Now again we are going to divide G2 of into 2 parts. That's why we have written n by 4. So if we calculate n by 4 value for 8 points, then 8 by 4 becomes 2, so which means you will get the only 2 points, that is n equals to 0 and n equals to 1. We have seen the odd value equation also. And this whole part is multiplied by, and in both the cases my n value varies from 0 to 1 only. So we will substitute 0 and 1 in both the equations. So first of all, we'll substitute 0 in this first equation. So after substituting 1, what I have got? G2 of 1 plus G2 of 3. So first sample, to get the first even value of G2 of n, what we can do? We will add even values. To get the even values, first of all, we have substituted 0 and 1. So first value of P13 of 0 you can get by just adding G2 of 0 and G2 of 2. And the second value of P3 of 1 you can get by just adding G2 of 1 and G2 of 3. Now we will calculate the odd part of G2 of n by just substituting zeros and 1 in that equation. So this is the equation. Now we will draw the graph for all these 4 points. Now, how to calculate P1 of 0? As I said, we have to just add G2 of 0 and G2 of 2. Similarly, P1 of 1 or P3 of 1 can be get by just adding G2 of 1 and G2 of 3. So we will draw the diagram or butterfly diagram for to calculate P31 of 0 and P31 of 1. Now you can get the value of P31 of 0 and P31 of 1 by just adding G2 of 0 with G2 of 2 and G2 of 1 with G2 of 3. So I have directly connected this line 2 G2 of 0 and G2 of 3 to G2 of 1 to this adder. So automatically your answer will be added. But same thing, we have to subtract G2 of 2 and G2 of 3 from G2 of 0 and G2 of 1. So what I am going to do, here we have a plus sign. So we'll multiply this line by -1 but after this dot. So what will happen, these two terms will be subtracted from G2 of 0 and G2 of 1 respectively. But to get this P41 of 0 and P42 of 0, what I'm going to do, we have to multiply these values by omega 4 is to 0 and omega 4 is to 1. Then you will get these values. Now we'll find out n by 4 point DFT for P1 of 0, P1 of 1, P21 of 0 and P12 of 0 and all these three values. So let's see how to find out. Basically we have studied one thing. N by 4 point DFT means what? If we have 8 points, which means if we have n equals to 8, then n by 4 DFT, which means we are going to calculate DFT for 2 points only. Now 2 points means what? We will calculate P11 of k and P12 of k. Now how to calculate P11 of k and P12 of k? For 2 points, which means we will substitute n equals to 0 to 1 value, and here we have P11 of n, and that will be multiplied with omega n to the power nk. Now, so first of all, for 2 points, your P11 of k values also you will get the 2. So first of all, we substitute k equals to 0. Then what will happen? This k value will be replaced by 0. Now anything raised to 0 is always 1, so you will get only P11 of n. Now I will break this summation value. So you will get P11 of 0 and P11 of 1 addition. But what about P12 of k? Here also we will substitute 0 value. So then what will happen? We will have n to the power 0, which means anything raised to 0 is always 1. So you will get, after breaking the summation, so these are the first values of even samples. Now you can say the G11 of n or G1 of n values for first even samples of x of k, or you can say the first even samples of G1 of n. Now we will calculate the odd samples by substituting n equals to 1 over here. I have substituted my k value as 1. So now I will break this summation value, or I will open the summation value. So first of all, I will substitute 0. This value is also replaced by 0. But basically omega n, we have calculated this value for 2 points. So this n is replaced by 2. Now anything raised to 0 is always 1. So we will have only P11 of 0. But if I substitute n equals to 1, then what will happen? Well, this k value is 1, so I can write here only 1, and n value is also 1. So my equation becomes omega 2 to the power 1. Now we know that omega 2 to the power 1 means what? The graph is divided into two parts. Either you will get 1 or you will get -1. So if we have omega n to the power 0, that which means you have 1. But when we have omega 2 to the power 1, which means we have a -1. So this whole P11 of 1 value is multiplied by -1. So I can write P11 of n will be subtracted from P11 of 0. Now similarly we will do the same thing with P12 of 1. Now here my k value is 1, so we'll directly write 1 into n is only n. Now I'll break this summation values. So first value I'm going to substitute, that is 0, and if n equals to 0, then anything raised to 0 is always 1, so I'm not going to write any value. Then I'll substitute n equals to 1. Now omega 2 of 1, as I said, omega 2 of 1 value is -1, so this sign is changed to minus sign, and from this you will get the idea of first 4 samples. So we'll draw the whole diagram of DIF FFT, but first 4 points I will draw, and then later on from that first point you will get the idea of next 4 point, but I will draw the whole 8 point DFT diagram, butterfly diagram of DIFFT. Now basically our P11 of 1, how to calculate P11 of 1? We have to subtract P11 of 1 from P11 of 0, but at the end we place the adder sign. So what we are going to do, I will multiply minus sign with P11 of 1, so automatically this value is subtracted from P11 of 0. Now how to calculate P11 of 0? Basically it is simply the addition between these two. So I will take one line and I will connect to this adder line which is connected to P11 of 0. So automatically you will get the value of P11 of 0 and P11 of 1. Similarly, we can calculate the value of P12 of 1 and P12 of 0. Now P12 of 1, basically it is a subtraction between P11 of 0 and P12 of 1, and P12 of 0 is the addition between these two. So what I'm going to do, I'll connect one line to this adder, so automatically these two values get added. But in case of P12 of 1, we have to subtract P12 of 1 from P11 of 0, but we have the adder sign. Then what we can do, we will multiply minus 1 but after this dot, so that after this dot this P12 of 1 will carry a negative sign and this will be subtracted from P12 of 0. So I'll do one thing, I'll connect one line of P12 of 0 over here to adder. So minus into plus becomes minus, so automatically P12 of 1 will be subtracted from P12 of 0. Similar calculation we will do the next 4 sample values, and I will draw the butterfly diagram using this. So look at here, this was the last part as we have drawn, and the next first part which is similar to the first one, and after connecting all the points with each other you can directly convert any x of k value into your x of n values. Now this is all about 8 point DIFFT, that is decimation in frequency fast Fourier transform. Now in next video we will study a numericals which is related to DITFFT and DIFFT. But for that stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.